Class, this is Mr. Roberts at Shasta High School, and I just wanted to talk to you about linear transformations of a function. So here we have a nice little function, f of x equals 3/4 x plus 5. We, of course, can see our x-intercept at positive 5, and from here we're increasing 1, 2, 3 units, and we're going over 4. I hope that's 5. 1, 2, 3, 4. Yeah, it's at 5. And there's four transformations that we discussed in class, and there'll be more later. But the four that we talked about so far is I can take this function, and I think I can actually just grab this. I can take this function, for example, and I can move this up or down. Right, so I can transform it up or down, and that's a pretty easy transformation to do. Mathematically, I don't think you'll have any problem with that. The other thing we can do is we can move it left or right. And honestly, if you think about these lines being infinite, it kind of gets a little confusing. Like, what's really the difference, since this line does extend forever? But I hope you'll see what's happening and what the difference is. But another thing that we can do is we can do reflections. So we're going to be able to reflect this across the x-axis and reflect across the y-axis. Now, for example, if I was trying to visualize a reflection across the y-axis, this point right here would just reflect to itself. But this point, it would be what? Up 1, 2, 3, and then back 1, 2, 3, and 4. So I think that point would be 1, and then up 1, 2, 3, and over 1, 2, 3, and 4. So that point would be a point. So what I have here with that reflection, I think I can kind of draw a line, is it's just basically this line that's going through like this. And if you look, that's a reflection across the x-axis. I'm sorry, that's a reflection across the y-axis. So you see every single point on this curve, every single point on this curve gets reflected to it. And there's a pre-image, and that's the image. So they're all reflected across to there. And then at this point, and then these points then are reflected across to this way. Right, they were over here. So the other reflection that we can do is we can do a reflection across the x-axis. That was a reflection across y. If I look at a reflection across the x-axis, it's the exact same things kind of going on here. If you look, I'm 5 units above at that point. Here, I'm going to be 5 units below. And also this point right here, I'm right at it. So this point would be on both. So I could pretty much do a pretty decent, convincing sketch of what a reflection across the y-axis would look like. It'd be something along this line right here, like this. And you can see, again, what's happening is I'm basically just taking everything that's up above, and it's coming down here. This positive point's becoming negative. This positive point's becoming negative. And then, interestingly enough, this negative point's becoming positive. Right? This negative point here is becoming positive. I hope you can see the pointer moving on here, not just the dots I draw. So let's talk about all four of those transformations. I'm going to get the rules down for them, and then I want to talk about how we use those rules to build a new function that behaves that way. Doing the transformation is not bad. Building the function that has that behavior that's related to f of x is a little different. And we'll probably keep coming back and referring to this particular function for all these examples. So let's just get rid of that. And let's go forward a page. So here's one of our rules, right? This one says that what this was talking about is if I want to move a function either to the right or to the left, what happens is my function, I'm going to transform my function by changing what I'm feeding into its argument. So instead of sending f of x just x's, I'm going to send f of x's minus h. So this value that goes in, this value that goes into the function is going to change. That was interesting. I don't know what I just did there. So we're going to come back and we'll look at this transformation, and we'll see that this is actually doing what I claim it is. One thing that's always been tricky for students each year is that this subtraction right here causes problems. because you're looking for a negative when you look inside the parentheses to see that it's going to move left or right. And remember, what we're doing is we're subtracting 8. So we may be subtracting a positive number, it would be moving to the right, or we may be subtracting a negative number. Remember, in the case that if you're subtracting a negative number, you're actually adding that value. So the signs might feel a little bit goofy to you. The other transformation we have here, I think, is much more straightforward, right? F of x is going to get mapped to f of x plus k. On the previous one, we were tweaking the argument, right? The thing that's inside of the function that's getting passed to the function. On this one, we're actually just adding something to the result of the function. So we evaluate our function, then add k's. And you can see if that makes sense, right? If I evaluate my function, that's what y is, and I'm just saying, hey, here's my y value, and I'm going to increase it by k. And I'll do that for all the y's. Or here's my y value, I'm going to decrease it by k in the case that k is negative, and I'll do that for all my y's. Now, our two reflections, if I want to reflect across the x-axis, my x's are going to become the opposite of what they were. And that kind of makes sense, because I can think if my x over was here at like positive 2, or positive 2, the opposite of that would be negative 2, and then I would produce the correct y. So we're gonna switch instead of feeding in x's, we're gonna feed in opposite of x's. And then the last one, in order to reflect across the y-axis, and this one makes the most sense of all to me. If I have some curve like here, oops, I have some curve. What I do is basically this says, if use your function to evaluate. Pick an x, use your function to evaluate what y is. So here's my x value. I plug it in the function, and it gives me this particular y value. And this says you're just going to take the opposite of that. So this is now going to be a point down here that's the equal distance away, right? So again, and if I do that for all the points, you can see that I'm getting a nice little reflection across the function. And all of a sudden, instead of having it go the positive way, it's going this way. And I don't think I can draw that very well, but I hope that you can imagine what that might look like. Okay, so let's go back and look at our original function and think about how we're going to do this, right? We had this function. In fact, let me grab it. Oops, I can't grab that whole function. I'll grab that. There we go. Actually, let me group these together as one thing. Oops, group them together. I'll just copy this whole thing. I'll go to this blank slide and I'll paste it in here. So I've got this function, and I want to, let's say I want to transform this function. Let's do the easy thing first. We're going to transform it up 5 units. So my whole goal is to create a new function that is exactly like this function, except it's 5 units above that function. So if I was to graph the new one, it would be hanging in the air 5 units above. Pretty straightforward to do this. So let's think about this. The new function I'm going to build is going to be called, I'm going to call it g of x. So it's not going to be the same function as f, so I probably shouldn't use the same name for it. It's going to be hovering above f of x, and I'm going to call it g of x, hovering 5 units above it. And g of x is going to look a lot like f of x, but because I want it to be 5 units above it, what it's actually going to look like is it's going to look like exactly like f of x, plus I'm going to increase it by 5 units. So this notation is just telling me how do I build my function g. And what it says is well, I'm going to need f, right? And this is f of x. And then once I have the f of x, I'm going to just increase it by the value 5. So if I go ahead and build that, it looks like this, right? I've got g of x, and that equals f of x, which is 3/4 x plus 5. 3/4 x plus 5. And you can see I just copied everything from f of x into this spot. And then I need to increase it by 5 again. Now, once I do that, the next thing and the last thing I'll do is I'll simplify this expression. So I'm going to simplify g of x. I'm going to rewrite g of x, and it equals 3/4 x plus the number 10. So here's my new function, right? 3/4 x plus 10. And it looks a lot like my previous function. It's just hovering 5 units above it. Now if I come back and I look at this, for example, let's write down, I'll write down what g of x was, right? I found that my new function g of x equals 3/4 x plus 10. And you can see, like, yeah, it's got this new y-intercept is exactly where I want it to be. So this right here is one of my new intercepts. Same slope, so I'm going to go up 3 units and over 1, 2, 1, 2, 3, and 4. Good thing I got my glasses on. I could go down 3 units, 1, 2, 3, and then back 4, 1, 2, 3, 4. There we go. So you can see all these points right here are defining my new line. And if I was to, grab the line tool and just like kind of like, hey, it's right here. Of course, it goes on forever. But what we see here is now I've done what I thought I was claiming I was doing. I've created a new function. This new function is named g of x, and it is exactly a translation of my old function f of x up by 5 units. Okay, so we've done going up, and I said going up I think was easier than it looks easier anyways than going left or right. Now let's go ahead and take a look at what the left or right looks like. Whoa. Let me grab my eraser. I don't want this function here anymore. And I don't need any of these points. I don't need that. I do, let's see. I don't know how I can get rid of this line. Oh, that's good. I can cut it. There we go. Okay, so now again we're going to take the same function, and this time instead of moving it to the up and moving it the upward direction, let's take this thing and move it 7 units to the left. I'm going to go 7 units to the left. So all this g is old g. This is not what g is anymore. Right? So I'm going to get rid of all of that. All of you are gone. However, I am going to still start with the same function f. So I'm going to leave it right there. So my new function g, I can't wait to write this down. So g of x equals, now, again, we're taking f of x and we're going to move it, I said 7 units. Will that fit on the graph nicely? It'll kind of work, I guess. We'll go with it. We're going to move it 7 units to the left. So, okay, I think I could do that. So here's the mapping, right? If I want to move left or right, the rule that I'm using, and I'll go back to it, is this one right here. And I want to move to the left, so h has to be a negative number. So I'm going to put a negative number into this transformation. So it looks like this, right? It equals f of, now, I'm modifying the argument that gets sent to the function f of x. I'm no longer just going to send it the number, the value x. I'm going to send it the number, a new number. And you know what? Looking at this, man, 7 would be a terrible transformation. Let me move it 4 units to the left. So I'm going to move 4 units to the left. And you'll probably be able to. It doesn't matter. It doesn't matter. Okay, so I'm going to move it 4 units to the left. Now, when I do this, okay, instead of sending it f of x, I'm going to send it f of x minus a negative 4. Now, I wrote it down like that, but let me write it again, simplifying that, right? G of x is going to equal f of x plus 4. Now, I'm ready to figure out what g of x is, and I want to write it down. And look at how I interpret this, right? The function g of x rather, is the function that you get when you take your function f, and instead of sending into it x's, you send into it this expression x plus 4. In other words, this becomes the argument into my function. So instead of just taking an x here, I'm going to replace this x with an x plus 4. So g of x then equals, not f anymore, now I'm going to write the function. It equals 3/4 times the quantity of x plus 4, and then I'm going to have a plus 5. All right, so if I look at this, I'm going to use the distributive property and then collect some like terms. So g of x equals 3/4 of x plus 4 times 3/4 is 3. Now you see why I chose to switch from 7 negative 4. And then I'm going to add 5. So my simplified version, my final version of g of x is g of x equals 3/4 x plus the number 8. Now, again, my claim is that this function right here is going to equal it's going to look like my original function, except it's going to be 4 units to the left of my original function. So let's go back here and graph it. So here's the result that we got. And let's go ahead and plot that, and I'll use a nice, I don't know, color green again. Green looks good for me. So I'm now going to start with a y-intercept at 8. So I'm here at 5, 6, 7, and 8. So a little bit of change up here, right? I went up 3 units this way. Now I'm going to follow my slope pattern again. My slope is up 3, 1, 2, 3 over 1, 2, 3, and 4. Put a dot there, Roberts. And then up, did I do that right? 1, 2, 3 over 1, 2, 3, and 4. Up 1, 2, 3 over 1, 2, 3, and 4. Okay, I think I'm doing that right. My eyes are not good. Let me grab my, you know what I'll do is I'll just copy this line. So I'm going to grab this line, and I'm going to clone it. With a clone, I'm just going to drag it over here and line it up. Now, what I want to check out is down here, right? Now, how this should have looked is it should be like this line got shifted 4 units that way. So when I'm looking down here, and it's kind of hard to like verify that, because unfortunately this function didn't have really a very nice x-intercept. But when I look in this zone right here, my claim is that these points are all 4 units apart. And I don't see any place where it's really, well, this is not a bad one, right? From here, 1, 2, 3, 4. That's pretty convincing, right? 4 units that way. 1, 2, 3. Yeah, actually, that's really convincing, isn't it? 1, 2, 3, and 4. That's 4 that way. That's so cool. So what I've done here is I've moved this function. It's gone exactly 4 units to the left of where it used to sit. So I can look at these two functions and I can see how are they related. It's kind of weird, you know. I mean, it is true that g of x is 3 units above f of x, but it's also 4 units to the left of that function. So kind of interesting, the relationship between those two. You know, the linear function, it's kind of difficult because when you look at them, it's hard to see really the difference between transforming things up or down, left and right. When we look at other curves, like for example, a cubic equation or a quadratic or something, it's real easy to see the difference between moving things up or down and left and right. Okay, so let's move along. I think let's go ahead and do the thing where we create a. Let's create a. Is there a way that I can insert a blank page? There we go. Let's do the thing where we create a reflection across one of the axes. So so it's going to be the same sort of thing. Let me write down my rule for the reflection across an axis. So we'll look at, that's a red pen. We'll look at f of x gets mapped to, let's see, this will do a reflection across the x-axis, the opposite of f of x. So basically what's happening here is I'm just going to take all the output values and quickly change their sign before they get plotted. So that's what I'm doing. That's the mechanics for each step of it. But let's write the function g that does that for us. So the function g of x, right, is going to equal what f of x was, but not f of x. No, it's not f of x. It's going to equal the opposite of what f of x was. The opposite of the output. Now I forgot what f of x was. F of x, the function was 3/4 x plus 5. Okay, so f, just to remind myself, f of x equals 3/4 x plus 5, and I'm ready to build my new function g here, right? So g of x is going to look like the opposite of that function. So I'll just put it in parentheses. I've got 3/4 x plus 5. And I can distribute that, right? And what do I have? Negative 3/4 x, and then minus the number 5. So all of a sudden, this thing right here, you can see what it's doing. It's just totally flipping the whole thing upside down. Let's go back to the place where we can kind of graph it and sketch it. So right here, and let me just erase a few things. Goodbye, goodbye, goodbye. And I can't use this line again because clearly this is going to be, you get rid of that. So let's go ahead and plot that now. So the function that we came up with was that it's going to equal the new function g of x, which is a reflection across the y-axis. G of x equals negative 3/4 x, and then minus 5. It's going to be really interesting too to see, because it should come right through here, and this line should be doing this kind of thing right here. So let's plot this. I start right here at my 1, 2, 3, 4, negative 5, and I'm going to use a different color, beautiful green dot. And then I'm going to go down 3/4. So down 1, 2, 3 over 1, 2, 3, and 4. Sweet. And equivalent, I'll do it again. Down 1, 2, 3, and over 1, 2, 3, and 4. There it is again. And I can go the opposite way. I can go up 3, 1, 2, 3, and back 4. 1, 2, 3, and 4. And you can see it's exactly what we thought it would be, right? Let me grab that line. And here at the line, I'm like, pretty good. So again, what have we done? By using that rule, and let me write it down again, right? By using this rule that f of x, right, f of x gets mapped to the opposite of the function f of x, right? We were able to use that rule to build this new function g that behaves exactly the way we thought it should be, right? Here's this function, and this function below is a reflection across the y-axis. Now there's one more thing. Video's up to 21 minutes. I'm sorry if you're watching this, man. I apologize. I'm just going to go ahead and finish and do the one thing that I haven't done, which is I haven't done a reflection across the x-axis. So, I just messed up my original function. So let's do, no, reflection across the y-axis. I just did the x-axis. 3/4 x, and then this was plus 5. Okay, so let's go back up and look at that rule that does the, that's the rule that does, well, there's left or right, right? I've changed my minusing inside of the argument. This is up or down. I add to or subtract to the result. A reflection across the x-axis is right here. We just did that, right? F of x gets mapped to the opposite of the f of x. And to do a reflection across the y-axis, f of x is going to get mapped to, it's going to be transformed to f of the opposite of x. So let's go ahead and do that one, and I'll just add a blank page here. And our function again was f of x equals 3/4 of the x plus 5. And we're building a new function g of x. G of x is going to be a reflection across the y-axis. So like we said on the previous slide, we're going to be using this rule. It's going to f of x is going to get mapped to, whoa, that was funky. It's going to get mapped to f of the opposite of x. So if I do this, right, it's g of x is going to become f of the opposite of x. So what this is telling me again is that this value right here, negative x, is what's going to be passed into this function to produce this transformation. And when I do that, g of x then becomes f. No, I'm not writing the f now. I'm actually doing it. It's 3/4, and then instead of times x, it's going to be times negative x, and then plus 5. So if I simplify that, it's now negative 3/4 x plus 5. So this right here, this g of x, this should be exactly what I need to produce a reflection across the y-axis. So let me grab that. Oh, not that. Let me grab this and go, what? Get back over. Are you kidding me? Grab this, and I'm going to take this whole thing and group it and bring it back to our front page. Groups. And I just realized that I can look at all these pages right here. Let's see now. Oh, there. So this is where we left off, and I'm just going to paste it here, edit, and paste, edit, and paste. Really? Um, I forgot I could just pause the video and fix things, and then you don't know what happened. So anyways, this was the function that is the transformation here. We've got a reflection across the y-axis. Um, we do have the same exact y-intercept. The y-intercept is going to be up at 5. And then from there, we're going to go, now we're going to go down 3, 1, 2, 3, and then over 4, 1, 2, 3, and 4, and that's going to be a point. And then down 3 and over 1, 2, 3, 4. So that's probably enough there that I can go ahead and grab the line tool. And I'm trying to, oh, that's not going to work. No, that's definitely not going to work. That's pretty close, yeah. So again, what we have here is we have a reflection across the y-axis, right? You can see this point gets mapped over to that point, and that happens for all these points. You know, I thought I'd just end with quickly showing all those transformations using GeoGebra. So my function was 3/4 x and plus 5. And you can see it wrote it very nicely in function notation. F of x is 3/4 x plus 5. The first thing I want to do is let's go ahead and do the reflection. We'll do them in reverse order, I guess. We'll do the reflection across the y-axis. So in order to get that, that's going to be f of the opposite of x. So watch when I do this. When I type enter, it created this new function it called g, right? And you can see that g is equivalent to what we ended up writing, and indeed it is a reflection across the y-axis. I'm going to take my original function again, it's the one right here, and I'm going to now take that and do my reflection across the x-axis. So I'm going to say it's going to be the opposite of f of x, right? So before it was I did f of the opposite of x. Now I'm saying the opposite of f of x. And that's exactly, it looks surprising to me, but yeah, that's right. This is, if you look at each of these points, they're reflected down to the part below. So this gets reflected to here, stays reflected, okay. Now let's go ahead and do the thing where we moved it. I think we moved it up some units. I can't remember how many we moved it up, but let's just, I know that we moved it to the right. No, we moved it to the left 4. Let's do that. If I want to move this to the left 4 units, that would be f of x. So I'm going to the left 4. So it's going to be minus a negative 4. So it's going to be f plus 4. And when I do that, I should see this curve right here get shifted to the left 4 units. And I do. Let me just grab that and move it over. So it's not, it's not exactly right. But if I go from 7, 8, 9, 10, 11, you can see it's just shy of 7. And then right there, it's just shy of the negative 11. So there's exactly 4 units between those two. You're like, really? Are you sure? Yeah, I am. And actually, if I had some time, I should grab some segments and construct them and measure them and demonstrate it. But hey, this video is already 28 minutes long. So the last one we did was I think a shift. I can't remember what we did originally. Was it a shift up, down, left, or right? I don't remember. Let's just go ahead and take our original curve. And by the way, I want to take this original curve right here, and let's make it a different color. Here we go, object properties. I'm showing you some, maybe like how to use some of the GeoGebra. I could pick a color. I'll pick like a color red. And on style, I'm going to make it like a thicker line. There we go. So I'll say okay. So there's my original one. Here's right here is my reflection across y. This line is my reflection across the x-axis. This line is when I shifted it 4 units to the left. And then finally, let's take this one so it'll fit in the screen, and we'll just shift it down. We shifted it up 5 units before. Let's do that just to be consistent. We'll shift it up 5 units. So to go straight up, I'm just going to take f of x, and I'm not going to modify the argument. Instead, I'm going to add an additional 5 to it. So when I do that, it's way off the screen there, but you can see, yeah, it was hitting 5. Now it's hitting 10. So in this one little picture here, we see the 4 transformations that we're talking about in this section. The transformation of the function f of x. We can reflect across y, we can reflect across x, we can shift up or down, and we can shift it left or right.
with the function notation and the transformations. Thank you very much for watching. A little secret on the YouTube, you can affect the playback speed. If you play this, 3 times fast, you'll see I sound like a chipmunk and the video doesn't last as long. Until we meet again.